Yeah. Hello, everyone. This is a SIG Scheduling meeting, 5th of March 2026. We have 3 items in our agenda today, and the first one is from Ryan.
Would I be able to share my screen? Is that okay?
Yes.
Oh, I already got persons. Okay, perfect. Okay. Hi everybody. I'm Ryan Halsey. I'm from the working group Node Lifecycle, and I I work at NVIDIA, and I'm working on a CAP as part of the working group Node Lifecycle called Specialized Lifecycle Management, and I wanted to share it with the scheduling folks here. And I've been going around to several SIGs and talking about this idea. Um, this CAP that I'm working on, I've targeted for 137, and so there's a bunch of discussion I think that has yet to be had on it. And so I wanted to, build feedback from different SIGs and, get your 2 cents. And, from this group particularly, I think there's a component of this that would impact scheduling. And so the background for this CAP actually goes to another CAP that I linked there. It's this one, the declarative node maintenance. So this is declarative domains. You probably have seen it around. It's been around for a little bit since 2023. So from the Node Lifecycle Working Group side, this we had discussed this CAP, and one of the things we had aligned on is that the scope of this CAP we wanted to change it. This CAP was focused on doing maintenance on a node, and we wanted to change it to be doing maintenance on resource APIs. So the scope was going to change entirely away from just focusing on a node to also think about like devices. And essentially what that meant is that we really needed to rethink how we wanted to accomplish this. And so this KEP was about doing lifecycle management on node. So now the specialized lifecycle management is focused on how can we do lifecycle management on devices, nodes, really any resource API. And so particularly for this group, the scheduling, the SIG scheduling, I think like why does this like why work on this? Why does it matter? Um, the way I'd say that is if we look at DRA, DRA has obviously had so many changes and such impact in Kubernetes and the way that it has redefined this how we think about allocating resources. And while we're working on DRA, and actually what I would say is that DRA is kind of like defining the redefining the day one of these machine learning AI workloads. Like how do we do workload aware scheduling, for example? It's like it's very focused on day one through DRA. And so my proposal for specialized lifecycle management is to say that while we're looking at and building out a lot of the day one through DRAs, that we start to think about what would the day two look like? What would it look like to lifecycle these devices now that we've brought on all these new devices, these distributed hardware systems into our data centers and with them the workloads and their requirements. What does it look like? And I think and that's a challenge. I think that's actually a really challenging thing. And I think just to highlight that particularly, I think if you were to look at today, like a 50, well, let's say like a NVL 72, like if you were to do you know, a today deploy machine learning job on an NVL 72, um, how would we handle cases where we need to do maintenance? How would we handle failures? Right? There's a lot of questions that go into that, and so that's what I wanted to address with this CAP is actually come up with some APIs that we can make it so that across the ecosystem we can define life cycle through these APIs, and then a bunch of different components can actually use these APIs for doing life cycle management. Are there any questions about the context that I can answer? I can go into some more detail um, about the some areas in SIG scheduling that we can talk about.
So if I understand correctly, we are about to define that not only some nodes, but also some devices can go into maintenance mode. And the extension is to cover not only nodes, but also cover devices.
Yes, yeah, that's right.
Here. Okay, I remember that we were discussing the eviction API itself. Is it still going to be used, or is it? I noticed that there are some state transition objects, so you can like get more into details.
Yeah. So the one note about that, the eviction API, and I think Philip, I thought saw us here. So the eviction API has been merged for 136, so approved for 136. The focus of the eviction request API is on pods and actually like the termination process of pods and what that entails. So like specifically like getting into the business logic of the application, like how should you terminate, like what's your process. This KEP is focused on, I would say, on the node level. So pod level for eviction requests, this would be like the node level, and node level including the devices. So I'll say resource APIs, all of the resource APIs. So a different scope, a bit broader.
Okay.
Okay. So yeah, go ahead.
Yeah,
There's more process.
if you have.
Yes, sure. So let me go into some more context about the scheduling side of things. So um, on the scheduling side, like, why does this matter for this group? So when we're doing scheduling, right, we're of like on a large rack of GPUs, like we're essentially what we're doing is like we're trying to from the customer perspective, they want to get 72 GPU system that's presented as a single GPU, right? And so like the customer sees this in the aggregates, but we obviously see this in the disaggregate. So we're scheduling is that we need to do things like aligning to single GPUs and single nodes. Like that's how we would look at this from the scheduling perspective. It's the same from the lifecycle perspective. It would have the same requirement. And so, for example, if you were to think of the scheduler, if you were to do placement of on like an NVL72 system, and you're scheduling pods, the appearance of all of those GPUs across that system are the same. And I mean like not in like PCI address, like I mean like their constitution, like their health, their all those things, they appear the same. And one of the things that's sort of difficult about this is that they aren't all the same. And we kind of know this because the hardware is distributed, right? It's a complex system. And for example, you would never know if like on tray 0, GPU number 3 is gone through is sort of degraded, right? It's gone through so much current through its systems, and one of the transistors has gone through some sort of failure. How would the scheduler know about this kind of thing, right? And so these kinds of things, like the GPU could be functional, but like, is it as functional as GPU 1 or GPU 0 on the tray? So that's like the difficulty is that, again, like we're presenting a 72 GPU system as one unit, but every single GPU and NVLink and NVSwitch have to function at the same level in order for us to to achieve a workload that works well for the customer. And if there's any sort of weak link, then you can lose money. The customer can lose money on the training, the training might not be as good. So the point is, like, in the scheduling sense, if we had this ability to say a choice between two GPUs or even two racks, to say, well, there's one GPU here that we run a lot of current through, right? We know that like we have these mean time between failures where we know if we run a lot of current through, that there's sort of a mean to say like one's more likely to fall over or fail, whatever it is, than one that hasn't. then you can actually make estimates and prediction as to which one that you would like to schedule on. There's one that's actually would be more an ideal placement than the other based on just the amount of current that has gone through its system. And in a sense, they're actually both healthy GPUs at a very high level, but one is just more likely to go into a failure if you were to run it for much longer. So this is the kind of thing like a customer might care about, or a person running doing the scheduling might care about, because you'd want to get the ideal placement. Does that make sense? Do people have questions about that?
So I guess, yeah, I mean, that makes sense. I'm wondering what, and I guess, you can just tell me to RTF. So we have device taints, right? And it would seem like that would handle the case you're talking about, because you could taint it with a degraded state. Is the lifecycle management like an orchestration layer on top of that? Like you're like on top of that, and the eviction, like is it kind of like the orchestration layer to control all these lower level APIs? Is that the idea?
It's part of it. So the device taint part, John, like if you were to say like taint something degraded, like what's the expectation from the scheduler like that you want?
Right now we don't have any, right? We haven't defined a taint that would make sense there. Like we have so we can attach the effects we have are no exec, I think there's, what is it? It's like no schedule, no exec, and none, or something like that. So one actually evicts, one just holds you off from scheduling completely, and the other just doesn't do anything. It's informational. So yeah.
I see. Okay. Yeah. So I guess where I was going with this is, so like the taints are good. Like it's like one of the things that's helpful. So one of the things though, like that I wanted to get at for a use case is that like if you had, I'll go back to the example. If you had two racks, one of them has got, we'll say like more likely to fail, like rack number one, versus rack number two is like less likely to fail. Rack number one's still okay. Like we could still use it. Like say if we're at peak time, it's still okay. Like we can schedule on it. It's just maybe we don't want to schedule like the really big customer on rack one. Like maybe we want to schedule like a different customer there, or maybe there's added risk, right? The point is like there's sort of risk in scheduling there. So we sort of, what would be the ideal placement based on the two? It would be that we would go to rack two where we are less likely to fail. But if we're at peak, we need both. So the point is that it's not really a binding contract, is to say like if we were to share the state, it would just be more like if you had a choice between the possibility between those two of them, you might pick one or the other.
So basically scoring.
Yeah, it's a scoring thing, right? Yeah.
Yeah.
So in your proposal, how is that accomplished? Like what is the API for that? And I don't want to, I know much of like, I don't know what your time frame is or what other things are on the agenda. I'm sure Ryan could, and we could talk all day. So, but I'm curious, and that's what I'm saying. Like, I haven't read this in depth yet, even though you've been asking me to for a long time. I apologize, but and so I don't want to take everybody's time just because I haven't read it. But my question would be like, what is the API for that? Is the taint API already there? Could be used for it with a new effect? I understand the idea of lifecycle events, a lifecycle orchestration, and that seems really important to me. I'm just not clear on how it trickles down.
So let me fill the gap, and I I apologize. I know like we do. There's probably other agenda points, and we have KubeCon coming up too. So it's okay. I haven't read this yet. We'll probably talk about it at KubeCon. I definitely would want to. But the way to look at it is like, so the taint. So if we had the ideal taint would be like, with scoring, like you had some sort of way to score. So now that's part of the picture. That would be helpful on the scheduling side of things, and that would be useful. Now, the other part of this is what you just said. It was like the larger lifecycle system, right? And the larger lifecycle system that would also want to consume the same API. So is the larger lifecycle system, is a taint the right API for also the larger lifecycle system? Like a taint works really good for the scheduler, but it's a little bit different for the larger lifecycle system because usually when you have a taint, like we also want to think about the rest of the life cycle, like training and there's so many things that could come up with rebooting, and there's other valuable things that we'd want to have. And so my proposal is to have a single API for this, and then we could sort of integrate the larger lifecycle system on that API and have it communicate with the scheduler, and where a scheduler might care about certain lifecycle events, and then other projects, like we can come up with a thing that does maintenance, something that schedules maintenance. There's like a whole ecosystem of things you can build on top of a system like this if you had the APIs and a way to express it. So that's sort of the larger picture, is that a taint kind of works really well with the scheduler. There are other requirements that would be needed for the larger lifecycle system. And so my proposal is that maybe we don't do it in a taint, maybe we can do it another way.
But note that taints comes with tolerations. So depending on what are your workload requirements, you can tolerate like bigger or smaller risk. Is it also something that could be expressed?
Yeah, that would be interesting. Yeah, I mean, I think that goes back to scoring. I think, I do think that you could tolerate risk with you could use tolerations to tolerate certain amounts of risk. You could also like express your risk in different forms, right? And like numerically. So and then you could have, tolerations for certain numerical amounts of risk. I don't know how that would look with taints, but that would be a use case.
Philip, you're rising a hand.
Yeah, I just want to add on the topic of taints. Like if we look, one of the things like we would also like to solve is like normal like node maintenance and like the state of the node and how do we get to the maintenance, how it proceeds. And in these scenarios, taints are like usually not good enough. Like they are not granular. So basically you need as you said, like Dominic, you need like the appropriate tolerations, and you basically every workload needs to be aware of like what's happening, or you need to have some like clever like admission webhooks or something. But it's like problematic with taints, so they are like very broad, and but like one of the things like we would like to solve is like how to have like observability of all the things that are happening during the node maintenance. So for example, like we have like special workloads like daemon sets, or like when you are progressing to like a graceful node shutdown, like we need like a mechanism to communicate like what's basically happening during the node drain. So like we can run like a certain set of applications at certain time during like gradual shutdown of the node, and at the end like there will be only like the last workloads that basically are necessary for the control plane. And so like the observability is a big part. Like as Ryan was mentioning, he like maybe he can show the API. We would like to start like with the API, like to basically have a very simple API that we can like evolve into the future to basically cover all these like edge scenarios and observability cases.
Yeah, especially so because you are covering both like taking some resources into maintenance, but also into some degraded mode. Is it in both cases like the same process of the transition to the more degraded mode, or are those completely two different flows?
I'd expect it to be a part of the same process, just like one of the steps in like the journey. So like, you can think of it as like if we have like this mean time to failure where we know like probabilistically you're gonna fail soon, then we're gonna like make note that we would like to take you offline. And if there's an opportunity to do it, it's something that's not going to interrupt a customer, then it would, we can take some sort of opportunistic maintenance. But if not, then, we just make note of this and it can be useful to other parties. So eventually the point is that you could be in this degraded state, you can further degrade, and then eventually, you're going to be forced into some sort of maintenance and whatever the RMA reboot cycle and brought back.
And do you think that everything could be like translated into taints so that scheduler will simply translate implicitly, maybe not necessarily in API, but that scheduler, is it enough that it will interpret it as a taint and simply stop from scheduling on those resources? Or do you think there needs to be a specific implementation for scheduler? In particular, do you expect scheduler to stop the kill some pods, or some other external controllers would keep doing that?
So it depends on the step of the life cycle. So on where like the taints would, where I think taints would come in. When we're at the point where we're like firmly saying we don't want to be scheduled there, then it would make sense to use taints. We can, no schedule tainted. That makes sense. I think the drain aspect of it has a whole nother layer of complication. I mean, it really depends on the end user. If the end user finds that if they want to define drain in such a way that through taints, then the end user can do that. But drain is so complicated that there's like a million ways you can do it. I mean, we have the whole eviction request API that goes into like all the different ways to enable complicated drains. And I mean, it's very much end user specific. That I'd say one of the drains could involve a scheduler, but there's 50 other that might involve complex applications that have to coordinate with one another. Sometimes you don't do full drains, like you leave daemon sits around. Sometimes you need to do ordering. Sometimes, you need to do backups. I don't know. I think like so I think the taints themselves the existing ones today will be useful, but I think what we require is something else on top to coordinate between, information that's valuable to the scheduler, but also information that's valuable to the larger lifecycle system.
Okay.
Yeah, I think like the coordination like is the important part. So like you can have like multiple like components or integrations, and basically every like project that's doing, for example, node maintenance or some other components have like different solutions. Maybe they are using different taints, maybe they are using like the unschedulable field on the node, and all of these like do not interact very well with each other, and your workload or they even like cannot predict like what's happening and what should happen. And I would expect like we might be adding some like primitives new primitives for scheduling that could be used like for example partial scheduling. So as we are talking right now, for example, like daemon sets and other workloads might like want to run, and some others should be basically evicted. And like what we would like to see is like have like a proper ownership of these like transitions. So like you can so you can have like different implementations, and they can observe like what's happening and what should happen.
Yeah, I think the idea of separating out like that these events are happening and that something needs to react to these events, and then that what those reactions are, right? And so like at the scheduler layer or the other components layer, I would hope that what those actions are would be like actuated just by using whatever existing APIs we have, when at all possible. Obviously, you find the gap. Oh, we want to express this and we can't with the existing APIs. Like, there's no way to layer in a scoring weight or a scoring adjustment or something. Then that becomes a separate, like, okay, we need a new API for that. But I wouldn't want to couple. My point is, I wouldn't want to couple like the lifecycle API objects directly to the scheduler if we can avoid it, right? The decoupling is important as much as possible. So, right, so like, I think you just said it, Felipe, like, okay, you've got a way to specify what the lifecycle transitions are. Then you've got a way to specify when those lifecycle transitions happen, what do we do about them? It might be write a condition, right? Like you've got in your node here. It might be write a taint. It might be flip a field, right? And each of those state transitions, but it's just actuating on existing APIs unless we find a gap that there's no existing API to do what we need.
Yeah, I would agree. We would want to reuse those existing APIs to communicate specific intent. Yeah, I think that's absolutely, yeah. I think so. Yeah, I think that makes sense. I think like the only gap would be like how do we communicate that intent? Which is like what I'm talking about in the design. It's like how do we get that intent? How do we declare it and spread it around?
The other thing is, well, I think part of your lifecycle project, right, would have some sort of a resource that allows users or maybe application developers to define how their application should respond or to changes in infrastructure state. But one, I think, interesting thing you bring up, right, is this idea of probability of failure and like, or we're going to take it offline at this time. Like, I don't think right now we have calendaring in any of our environments. It's a super hard problem, which I think Wojciech maybe worked on that here like 10 years ago, and it was really hard. He can probably tell stories, but like trying to do the calendaring in the scheduler isn't something, as far as I know, we're approaching anytime soon, if ever. And so I don't know what to do about those things, right? Like, it's almost like we don't have it's not in our longer scope, as far as I can tell. I mean, you could do it through scoring, like you said, like, okay, well, avoid that machine if you can, because we think it's going to come offline soon. That's not really like we're going to take it offline at midnight on Tuesday.
So regarding calendaring, I think like what's being considered, there isn't as a decision, but what's being considered is like to try to do something in queue.
Okay.
So there will be other, or there might be other ecosystem like projects that would like to implement that too. So like, I think having the information to make that possible is definitely like useful. I don't think we will attack it in core anytime soon. So if ever.
Right.
That's
but that
fine.
makes sense.
Sorry, go ahead. I apologize. Yeah, it's mostly about, I guess, the information, elevating the information, like the observability aspect of it. Because if we don't attack it in core, that's fine. Somebody could attack it if we have the information, right? So I think that's the part. It's like the added value of it. Yeah, sorry, go ahead, John.
No, I wasn't going to say anything more useful.
Yeah, I think that the calendaring is probably not something essential here, I guess, because in a way we will simply react to the transition events, and probably we are not going to prepare, I don't know, try to adjust scheduling because there is a plant maintenance. So this is probably not in scope, I think, of this proposal. Or maybe I'm wrong, but...
No, I think I'm me raising it here is just to give the example like of like the power of observability, like that if this metric existed, what could we do with it? And so this is just me coming up with an example of like, what I could do with this, if I had a magic wand. But there's like, I think there are others, like I think that this idea of life cycling, I mean, you could even say like, like, so this would be one entry. This is like leaving or losing capacity. You could do the inverse and say returning capacity, right? You could also, that's another life cycle event that's interesting to people. I don't know if we would want to have this on the roadmap and the scheduler, but again, like you can understand the concept of like returning. We care about capacity, so leaving or returning. Maybe there's a way we could do something about that. I not proposing it that we do it, but somebody could do it at some point if we had that.
Yeah. And coming back quickly to those translation to taints and tolerations. So from what I hear, the existing mechanism basically should do everything that we need, but we need to have some layer that coordinates all of it. And I think we have two choices. Either this coordination will effectively create physically taints in API server that scheduler will react to, or we can think about somehow some implicit taints that scheduler can implicitly create in memory and simply apply them. I think we had similar discussion when we discussed some other feature, but frankly,
yeah, we talked about implicit taints before, but I think this group decided it was not worth the effort. That transitioned into node declared features, which has a sort of similar. It's a scoped down version of implicit taints.
Mm-hmm.
Implicit taints and tolerations, basically doing that, but only for feature gates and on kubelet, more or less. So
the taints in the array, because
that's at the device level. So the thing that, like, you have a node, right? Nodes have taints and tolerations, and nodes have conditions. We don't have conditions on devices. We could add that, right? It's just not something we have today. Actually, that's not. Yeah, we don't. We have it on the resource claim status, but we don't have any status on resource slice. So there's no equivalent to the node conditions. So that might be something that would, if there's a use case for it that Ryan has, like that could be really, we can add that, right? We just haven't had for now, we were just saying we'll put health information in taints because we don't want to create a whole new API.
Okay, so physical taints. So we need to be aware of races and so on, and the additional load on API server and so on.
I'm talking about the way device taints work today is that there's no, the way health information is attached to devices, actually today it isn't, right? Because taints is alpha still. But the devices are just withdrawn from the resource slice if they're unhealthy. And now we'll go to beta in 136 with device taints that allows drivers to write instead, hey, this device is unhealthy, don't schedule it. Or, hey, this device is unhealthy, evict any pods that are using it and don't schedule it. And administrators can do that too, kind of with a rule. And that was going to be, we basically on the health side, we decided that's all we're going to do for now until we see a specific requirement, specific use case that's insufficient.
Yeah, from my side, John, I think what it comes down to is when, like you said, the orchestration layer, the larger lifecycle layer. I need to figure out, like, if I've got this large aggregated system, like which of these GPUs I need to do. Like I could have 4 nodes and 2 GPUs across those, two GPUs across on each node that I need to lifecycle, or I don't know, any combination. And then you can get to switches and racks, and essentially you quickly get to topology aware maintenance, and that's like a whole nother thing. Upgrading firmware on one GPU requires that you need to upgrade the firmware on the other GPUs attached to the NVLink or the switch. And so like now that's like a whole nother complex thing that you have to do, because you might be fixing a bug, so you need the new firmware. And so there's degradation can be expressed that way. And so there's lots of, it gets very complicated.
So yeah, and so that I mean that means to me, and this is not maybe for this, maybe it's for the next call, Ryan, but like modeling some of these things as devices that we can have an abstraction for, that we can like take it all offline or online at the same time or whatever,
Yeah.
could be helpful there.
Yeah, that makes sense. Cool.
Okay.
Well, thanks everybody. If there's no more questions, thank you very much. I'll be at KubeCon and we can talk more for people that are interested. And I'll be at the Maintainer Summit as well. I'll probably pitch an unconference for this if we want to talk about it. We can talk about it there. So thank you.
Okay, if I can add a couple of points. Yeah, I think like we did not like especially focus on the taints yet. Like the purpose of the API is like for itself, like the instances of the transition like can serve as an API. So for example, you might have like some states that are useful for some kind of like deprovisioning of the node even beyond Kubernetes, and you can use this to communicate like to the provider or some other entity, like what kind of things should happen. And so like the implementation itself, like how the transition happens there, like it can use like any mechanisms like Kubernetes has today. So even the taints, and you can taint the node, and you can use like traditional eviction API or the new eviction request API to drain the node, and you can basically like tell the cluster that this kind of action is happening for this transition. Yeah, so I think like there are like very big implications for like SIG scheduling, but a lot of them are like coming much later.
Okay.
Yeah, so thanks, Ryan and Philip.
Thank you.
So yes, we can move to the next point, that is from Dominic about the peer review process.
Yeah, so like you're probably all aware that the capacity of reviews in SIG scheduling is a big it's a constraint for us. We have a lot of PRs to review. We have a lot of engagement from many people, so the number of contributors grew a lot. And we need to make sure that the number of reviewers grows as well. So we propose to a little bit more formalize the review process and let more people get involved into it. So to be able to grow into reviewers and later approvers roles. So I think what's the most important here is that we have the role of the first reviewer who can be assigned. This is probably laughing like completely new for for everyone, but I think we want to make the use of this process as much as possible. So expect from the first reviewer to like act as a main reviewer, so assess the complexity of the change, what kind of risks it imposes, and even suggest like whether another reviewer should be engaged, or this is something that can be just approved by an approver. Of course, reviewed and approved. So we have the list of our PRs that are in flight, and we have a dashboard. Maciek, you can open it. Yeah. So this is how it works. People can assign as a first reviewer and put some notes on the and report this progress of the review. It started working pretty well, I think I can say, and another important thing is our priority. So how we focus on PRs. So thanks everyone who is engaged, and anyone who wants to take reviews, you can let us know on Slack. If there are no more questions about that, another topic is moving the SIG scheduling meeting by 1 hour. So the next meeting will be moved only in Europe because of the time zone difference. So the time change in US is earlier and later in Europe. So because the meetings are tied to the US time zone, then it will be naturally changed to 6 p.m. Next time. And starting from 2nd April, it will be 9 a.m. in US. So
And Dominic, are we planning to stay in the US time zone, but 1 hour earlier, or move to Europe?
Good question. I don't have any strong opinion about this. I think, I don't know.
Yeah, me neither. Just the Asia meeting, I think, is on the Europe time zone. So we could
Of
align.
course, the difference will be that next time this difference will happen, okay, we will be moving. I'm not sure if we are always shifted in the same way regarding the time changes or not. I don't know. I don't have any preference. Sticking to US time zone sounds good to me, but
Okay. And we don't have more comments on this topic, I think.
Yeah. Of course, regarding the review status, we are waiting for API approvals, and this unfortunately takes time. Yeah. But hopefully we will move faster once we merge the critical PRs. Okay, any other questions or topics?
Okay, we don't have any more topics, so I think we can conclude the meeting. So thanks everyone for joining today, and see you next week or 2 weeks later.
Yeah, thank you.
Thank you. Bye.